Hi, this is Clarke Iakovakis. This is the video for session 2 of Bibliometrics for Librarians class. In this video, we will walk through the Introduction to Bibliometrics Lesson 1, which you should have cloned in the first video. So that is available on our website, which you can see in the address bar here. So if you haven't watched this video and done this step, do that first. This is the getting started with Jupyter Notebooks and R. So assuming you have done that, then you will have Intro to Bibliometrics listed under My Projects in your Microsoft Azure Notebooks environment. So go ahead and click on that Intro to Bibliometrics, and then click on the file for Bibliometrics Lesson 1. So this will start up the R kernel running in the background of this Jupyter notebook. I noticed that when I instructed you all to clone this notebook, I didn't clear the output. So if you want to start with a blank slate and clear out all of the output, then you'll go to Cell, All Output, Clear, and that will take it all away. That's optional and it's up to you. So the first thing you need to do is install the packages. As I mentioned in the last class, R is open source software, and a number of individuals have made packages that enhance the functionality of what R can do. Most active in the space of research and scientific packages is the organization R OpenSci, and they're the ones that have developed the packages for R Crossref and Citecorp. So I'm going to go ahead and press Control Enter to install this package, and it's installing right now. You can tell because the little asterisk appears here instead of a number, and that means that the code chunk is running. So I'm going to go ahead and click on this second one and do the same thing, Control Enter, and it will run as soon as this code chunk is finished. The other set of packages that we're going to use in this session are listed here. If you are using this in RStudio, you want to install the Tidyverse package. What this is it's kind of a package of packages that really help with doing data science and data manipulation in R. It includes dplyr, which is good for joining data together and transforming data. It includes purrr, which is good for working with lists, string R, which is good for working with character string manipulation, tidyr, which is good for tidying data if you need to move it from wide to long format, among other functions. readr, which is good for reading and writing data into the R environment, and Ggplot2, which is useful for plotting data. So the data that we're going to be pulling from is Crossref and Open Citations corpus. So each of these have REST APIs that if you know how to use an API querying tool, you can use that. You don't have to use our Crossref or Citecorp in order to query their APIs. The reason to use R Crossref and Citecorp is that it pulls that data directly into your R session, and then you can manipulate it in R all at once. So it's kind of like wrapping everything together. Also, R OpenSci has written functions that interface with the API that allow you to be specific with the kinds of queries that you're sending out to the API and pulling data in. These are all very well documented in these links. So the first step is to download article data, and we're going to use dimensions for that. So you do need to create an account with Dimensions, which you can do at app.dimensions.ai. And then you're going to type in Bibliometrics and with in all capital letters, and then quotation marks, open access. So this is going to return a set of articles that use the term bibliometrics and open access. Oh, and also be sure and change the search option to title and abstract. So this is going to return a set of articles that have both the term bibliometrics and open access somewhere in either the title or the abstract. And that will give us a nice, good set of citations to work with. You want to export those into CSV format, and that'll give you the data set. Here in the Azure Notebooks environment, I'm going to navigate back to it real quick and show you that I have already put that data into the data folder in the Azure Notebook that you cloned. So you don't have to do that step of actually getting the data unless you want to have a copy of that CSV yourself and go through that experience. You can also download this data set if you'd like. All right, so I'm going to jump back in here. We see that it's still installing that package because it needs to install a couple of dependencies. But so we'll wait for that to get done. I guess while that is finishing up, I'm just navigate over into Dimensions. You don't need an account to search and use Dimensions, but you do have to create an account if you want to download the data set. So just to replicate what I did, bibliometrics and then you can use the filters if you want to subset it more, which I did not do. Okay, that's finished installing. So the first thing that we're going to do here is read that dimensions CSV into our environment. So you can see we're calling read underscore CSV. We're specifying the folder and the name of the file. We're skipping the first line there because it's just some copyright text. So I'm going to press Control Enter. Oh, that didn't work because after you install the packages, you have to run this code block, and this will actually load the functions within these packages into your R session. So this gave me an error initially because I hadn't actually loaded the read CSV function. So now that I've done it, I'm going to run this code chunk again, and it'll give us a little star here. And it tells us that it was successfully parsed, and it gives us the list of all of the columns that came in with it. You can use the head function if you want to preview the first 10 rows, say. And we can see here we have some standard bibliographic metadata, like the publication ID, within dimensions, the DOI, article title, the journal title or source title, volume, pagination. And as we go over further, we see we have some citation metrics here, time cited, recent citations, RCR, which is the relative citation ratio, and FCR, which is the field citation ratio. So we're going to use some functions from dplyr to do some manipulations on the data. We're also going to use this pipe. And what that does is it takes the output from whatever comes before it and uses it as input for the next line. So here we're calling the dimensions data set, which we loaded up here. And we are using that as input, and we're going to arrange it by the number of times cited, and then we're going to look at the top 10 rows. So let's do that. And that will let us know the top 10 most cited items within this data set. So we can see the classic citation advantage of open access articles. And the reason that this was pulled into the data set is because in a mesh classification, it had the term bibliometrics. I think that we filtered it by abstract and title, didn't we? So I'm not, it must say the term bibliometrics in the abstract as well. But in any event, we have our top 10 most cited items here. Recent citations, so we can ask how this compares to recent citations, the number of citations received in the last 2 calendar years. And we can see that there are some slight differences. Citation advantage of open access articles, even though this article is almost 15 years old, I think. It was published in, 2006. It's still getting recent citations. So. We talked about relative citation ratio in class. It's only there for publications that are archived in PubMed. So in this case, I'm going to go through the exercise using the above code as an example. Write code that sorts the data set by RCR in descending order and display the top 10 items. So I'm going to call the dimensions data set. I'm going to use the pipe to use that as the output. I'm going to press tab, and that helps make the code more readable. I'm going to arrange that data set in descending order according to the RCR column. Then I'm going to display the top 10 items with head, and I'm going to say n equals 10, and then I'm going to press Control Enter to run that. And we can see the top 10 items ranked by relative citation ratio. If we move over here and take a look at that column, we'll see the RCR for this first one was 12. And that means that this item was cited 12 times more than expected for other articles cited in its co-citation network. Next, we can look at publication year. So within this set of articles, what does the distribution of publication year look like? We can use the range command for that. And that range will tell us the max and the min for each, for the column. So the minimum is 2004 and the latest one is 2020. We can use the group by function to look at the distribution of publication years. So what we're doing here is we're taking the dimensions data set, we're clustering it together by publication year, and then we are tallying that. So let's run that column. And this will give us a little perspective on the frequency. If we wanted to arrange it from the year with the most to the year with the least, we can just add a pipe command here and say arrange in descending order by, you can see here the column name that it assigns to tally is N. So we can add an N there. And now we see that 2018 has the most publications with 55. So in 2020, even though we're only halfway through, has 26. So clearly this topic of bibliometrics and open access is much more, there are many more publications within the last 5 years than in 10 and 15 years ago. You can also use Ggplot to visualize the data. So here, again, we're calling dimensions data. We are piping in a Ggplot. And to connect Ggplot commands, you use a plus. So we are going to create a bar plot, and then we're going to set the aesthetics. In other words, what's going to be on the x-axis and what's going to be on the y-axis and so on. So here we're just going to set the x-axis, and we're going to set that to publication year. All right, and we can see that, again, as we confirmed here, more recent years have a higher volume of publications. So we might also be interested in what journals appear in this result set. So here's what we're going to do step by step in this little chunk of code. We're going to start by using the filter command, and we're going to use complete cases for the source title column. In other words, what filter does is, or let's start with what complete cases does, is it looks at each value in the source title column, which I'm going to run up here to the source title column. Okay, it's going to look through each one of these columns, and it's going to see whether or not it's a NA or a missing value. If it is a missing value, it's going to be false, because the question is complete cases. Is it an NA or not? So for all of these top 10, it is not a missing value. The journal title is there, BMC Medicine, and so on. But there are some there that are missing. So I just want to filter those out immediately. I don't even want to see them. So that's the first step. The second step is to group by, which we used above. So that's going to cluster all of the values together by source title. Then we're going to tally, like we also did above, and arrange it in descending order. So let's take a look at that. And we see, as is not surprising at all, the journal Scientometrics has the highest number of publications here with 19, followed by Public Library of Science +1 with 13, and so on down the line. So if I had not filtered out the NA, there would just be one of these source titles would say NA, and it would have the number. So you don't have to filter that out, but it just makes the data set look a little cleaner. All right, so now let's get into actually getting references of the articles. So this dimensions data includes some citation metrics, but it doesn't actually include a list of articles that have cited this document, nor does it include a list of the references that are in each document. So to get that, we have to use citecorp. There are a lot of different ways that you can use citecorp. Here, so you can feed in a list of CSVs. So I could have taken the entire column, I'm sorry, DOIs, not CSVs. You can put in a list of DOIs here and return data for each one of those. I'm just going to pick one because, but I could have given it the DOI column from my data set here. So I could have done something like this. My site 2 gets, I could have said dimensions DOI, and that would have given me a huge list. Actually, I think it's capitalized, a huge list of articles. So I don't need that right now. But what this function does, COCI cites, is it will get all of the citations to this article. So I'm going to run that, and that will take a second while it goes out and collects those citations. I'm just going to print that here to the console so we can take a look at it. So here it gives us the cited article here at the end, which is always going to be the same, which, by the way, is this article, The Citation Advantage of Open Access Articles. So it'll give us the cited article, and then each one of these rows is a different article that has cited this article. And you can see this explains what each one of the columns are. So journal SC, this says whether or not this is a self-citation. So if the citing article came from, I think this was in PLOS Biology, the journal SC would be yes. Or if one of these articles was published by one of the authors of my target article, this would be a yes. So if self-citations were important to you, you could filter those out. There's also this column time span. This will give you the years, months, and days since the article, the citing article, the time span from when this article was published to when this article was published. So that too, if you wanted to filter out and say get only the last items that have been published in the last 5 or 6 years, you could do that. Okay, the next function I'm going to show is, obviously here we have just the DOI, but we don't have any information about what this article is. To get that data, you have to use the OC-COCI meta. And I'm going to put a little subset here in using these brackets and say I'm only going to get the first 50 items. I'm going to go ahead and run that because it takes a second. So using the my sites, which is the value that we picked to return this data to my sites, what this function is doing is saying my sites $citing. Citing is this column name here, which is the DOI for the citing article. Look at only rows 1 through 50 and return a, using this function, return a data set that includes the metadata for those articles. If you don't put this subset in Azure Notebooks, it will time out, or it may time out. However, if you're doing this in RStudio, it's not going to be an issue. So everything else that we see here, we're going to do some plotting of those data. It's just going to be for testing purposes because it's not the entire set of citing articles for the article that we have in mind. Okay, so that's finished. Let's run ahead and look at the top 10 rows. And now we have some nice bibliographic metadata where we have the DOI. This is a list of the citing DOIs. We have a link to an open access version, the journal title, the volume, the author, the title, and so on, your standard bibliographic metadata. And then in the last column, we have the references for this article. So this article, defrosting the digital library, these are all of the DOIs for the that article cited. Okay, now we're going to do a little plot of that. And so let's walk through this step by step. We start by using the mutate function, and what that does is create a new column. So we're going to use mutate to create a new column called year. And that column, there is already a column called year, but it got read into R as a character, which means that you can't visualize changes across time. It has to be an integer in order to do that. So we're going to use the asInteger function to what's called coerce it into an integer type. So that's the first step, is use mutate to coerce year into integer. Then we're going to run a ggplot, and we're going to do something called a frequency polygon, which is sort of like a histogram, except it is with a line plot. And we're going to use year as the x-axis And then we're going to set the bin width to 1 so that 1 year appears in each bin. And so, as I mentioned, this is only the 50 of the number of citing articles, so this isn't representative. But we can see that there was a spike there in 2016. And if we were looking at the whole set, we might be able to get a better perspective of what the data said, but you get the general impression. Okay, the other cool thing that you can do with Ggplot is you can add in a third dimension with color, so a third dimension to your plot. And so let's say we want to look at if there is a difference between open access, citations, the distribution of open access articles here by year. So here we're going to mutate again. We're going to create a year column and coerce that to integer as we did above. Then this is kind of a little tricky. We're going to create a new column called OA link. And what this does is, first off, it will look through the OA link column. And if it's an NA, it will say true. If it is not, it will, I'm sorry, if there is a value there, it will say true. If there's not a value there, in other words, if it's missing, it will say false. And then finally, we're going to create a new column that says OA available and run the complete cases function on that one, so that that will tell us yes or no, is it open access or is it not. I don't think I explained that very well, but you can read more here or ask me a question if you if that was not clear. So let's run that. Essentially, the idea was if there's an OA link, it's going to be in the green here, so it's going to be true. So we're able to compare the open access between the two different plots. So you can take that data and you can get it formatted into a BibTeX or RIS file and then read it into a citation manager, and explain how to do that here. You're using the CRCN function, which comes from our Crossref. So you can change this to RIS if you would rather it be in RIS format. You could also write the data to a CSV file if you would rather have it in a spreadsheet. So there are lots of other R packages that interface with publications metadata, and I list some of that here. Thank you for watching this video, and please let me know if you have any questions.